Hello, and thank you for watching this December 5th weather update, brought to you by Agrible, the makers of Morning Farm Report. My name is Eric Snodgrass, and I'm a senior atmospheric scientist and co-founder of Agrible. This past week's weather was wild, to say the least. We have been covering the incredible drought conditions in the southeastern United States, and thankfully, the heavy rains we forecast last week did push through the parched and burning southeast. Some locations received over 6 inches of rain. Unfortunately, these heavy rains arrived one day too late. Just after the release of our video last week, the strong southerly winds that circulated around the low-pressure system that dumped a lot of snow in the Dakotas and rain throughout most of the Midwest switched the wind direction in the southeast, where they had been fighting fires for weeks. Now, I know you've heard a lot about these fires through the news media, especially as they spread through the popular tourist town of Gatlinburg, but I wanted to show you 2 things that really stood out to me. So just to show you how bad it was, as these fires approached the city, a high temperature of 118 degrees Fahrenheit was felt in the city as the heat from the blaze blew through Gatlinburg on sustained 40-mile-an-hour winds that occasionally gusted over 60 miles per hour. And then, speaking of really high temperatures, this SUV was completely incinerated by the blaze, which we know must have produced temperatures in excess of 1,200 degrees Fahrenheit because the aluminum wheels melted into puddles of metal. And when the rain that you saw in that first slide finally did arrive in the southeast, several of the storms produced in this system were severe. Everything from large hail to tornadoes to flash flood warnings accompanied these drought-busting rains. Each of the outlined shapes that you see on this graphic actually represents a separate severe weather warning. And when it was all said and done, some 44 tornadoes were reported out of this system. Okay, let's quickly talk now about last weekend's weather. As we have been discussing, the ridge that brought so much of the warmth to the United States for October and November is gone, and in its place is a much more active jet stream. Now, one of the forecast models I'll be showing you a lot this winter is called the NAM model. This was the forecast it produced on Saturday, and as you can see, the model was predicting a large area of snow, the first of the season for many in Illinois, parts of Iowa, and Indiana. Now, I'll be honest, I was a bit skeptical of seeing snow in Champaign at the Agrible headquarters, since our forecast high temperature was around 35 degrees Fahrenheit, and the cold air that we needed to make that snow was really not locked into place just yet. So my forecast at the end of last week was for 34 degrees Fahrenheit and rain on Sunday. But I was wrong, and I think this is a really good opportunity to show you how it can snow when the air temperature is above freezing. Well, the scene you've been watching here is out my front door in Mahomet, Illinois. It was 35 degrees Fahrenheit, and we were having a very heavy and wet snow event. In fact, we call these big snowflakes silver dollar snowflakes. So one of the best tools that atmospheric scientists use to determine precipitation type is collected from a radiosonde, more commonly called a weather balloon. Now, weather balloons are launched all over the United States and all over the world, and the data they collect are among the most valuable for initializing our weather models so we can predict the future weather. The instruments that the balloon carries measure temperature, dew point temperature, wind speed, and direction as a function of height and pressure throughout the depth of the troposphere, which is the lowest level of the atmosphere. The weather balloon launched in Lincoln, Illinois on Sunday morning passed through the clouds that were making all of that snow right through here, where the temperature and dew point temperature lines touch. Now, can you see how the temperature on the ground at the bottom of this sounding was 34 degrees Fahrenheit in Lincoln, Illinois? In fact, if you look at this blue line here, which shows us the 32-degree isotherm, we can see how a lot of the air near the surface was just above freezing. So why was there snow? Well, as the snow fell from these clouds, it fell into drier air in the low levels of the atmosphere. And that can be seen right here where the temperature and dew point temperature lines are spread apart. Rather than melting, the snowflake sublimated, which is where the ice crystals essentially evaporate without melting first. You've probably seen something like this before, though, if you've ever seen the fog that rolls off of a piece of dry ice. Well, in atmospheric sciences, we track a temperature called the wet bulb temperature, which tells us how cool the air can become through evaporation or precipitation. It is shown on this sounding in the cyan line you see right here. If that line is below freezing, there is a high probability that even though the air temperature is slightly above freezing, that snow will be able to survive as snowflakes as they fall through some slightly above freezing air and hit the ground as a very wet snowflake. Now, when the snow is really wet like that, what we end up getting are big aggregates of snowflakes, which is what you see here. Now, this is a microscopic view of what snowflakes look like, but in the real world, this is what we saw on Sunday. Now, in the coming days, we will have no trouble getting cold enough air across the United States. This animation shows surface air temperature anomalies, which are differences from normal, as forecast by the GFS model on Sunday, December 4th, for the next 15 days. We're actually looking here at the average of 21 separate model runs, which is a technique we use to look for consistency in the weather. Well, as you saw in this animation, some bitterly cold air spread south out of Alaska. Now, this is a huge change over what we saw in October and November, and it will most certainly start to finally feel like winter. Well, here's the forecast, though, for the next 3.5 days in terms of precipitation type and intensity as forecast by the NAM model. First, we have another large system that pulls out of Texas and moves toward the northeast. This system will be primarily a rainmaker, since it will form ahead of that cold air that you just saw. But once this rain moves to the east, you can see the leading edge of the colder air funneling southward into the central United States on its way toward the coasts. So, this week will start off wet for a big chunk of the Corn Belt and finish very cold for nearly everyone. Beyond this week, there's a bit of uncertainty on the timing of the next large winter storm, but one thing is certain, the jet stream is no longer stuck in a permanent ridge in the central United States. Well, as we wrap up, I wanted to check in on the weather in South America. This graphic shows the percent of water storage in the soil, and essentially, Brazil's major growing regions have recovered soil moisture quite well this season. The only concerns I have are that Mato Grosso do Sul did have a pretty dry November, especially in the southern parts of that state. But more rainfall is actually forecast for this area in the coming days. So overall, the growing season in Brazil has started off fair, with no large-scale cause for concern. Well, as always, we at Agrible will bring you the latest and best weather forecast information through our morning farm report so that you can efficiently plan your operations. We thank you for your attention and hope you look forward to our next weather video update. Thank you.